Hello, this video is hypothesis testing for the mean population standard deviation unknown, meaning we only have the sample standard deviation. So this is going to be a lot like the way the t-distribution worked for confidence intervals. We'll just be applying it to hypothesis test. So here are the basic properties of the t-distribution with n-1 degrees of freedom. The population is normally distributed, and usually we'll see that thrown kind of a sentence in there. That means we're allowed to use the t. Population standard deviation is unknown. We use the sample standard deviation S. The third one's not really an official case. Usually n is less than 30 because the t-distribution is more often used for smaller samples, but that's not a rule. So that's not something you should follow, but it's very common. Now the decision rule wording is pretty much the same for t as it is for z. You're going to reject the HO if t is less than or equal to the critical value for left-tailed, which will be negative, and you'll see that coming up in a minute. Right-tailed, you're going to reject if t is greater than the critical value, which is positive. And then two-tailed, you're going to reject if it's in either end. It's either the negative end or the positive end. Now you talk about the Excel spreadsheet here in just a moment. Now I've got the calculator here. I don't know if you want to do this, you can, but I'm going to show you. You don't have to. We don't really need to do that since we have the spreadsheet. Okay. So here I'm showing a level significance, 0.03, n equals 10. So in the spreadsheet, you'd get this by the hypothesis testing spreadsheet. So let's see, left-tailed, 0.03, and you don't need any other numbers other than the level significance and the sample size, which was 10. We don't have to aim in other degrees of freedom, so there it is. Critical value there is negative 2.15. I'll come down here and do 0.03 for that one. And then 0.03 and 10. So if we look up here, the left-tailed and right-tailed values are always going to be the same. It's just left-tailed's negative, right-tailed's positive. So we can look and see what that shows here. You see there they are, negative 2.15, positive 2.15. Now this is the way I have this set up in the calculators to where it only shows the left value. You have to do it. You can't show them both at the same time in the calculator. But the spreadsheet then shows you both negative and positive. So to get the critical value, all you need to do is put in the level of significance and then the sample size. Now to do the other stuff we're going to do, test statistic and all that, that's where you got to put all the other numbers in there. So it's very important. Well, first thing is you want to make sure when you're using this file that your problem's either going to be z distribution or t distribution. That's the first thing you want to check. So if you're running any like error situations in the homework, check that first. Check what tab you're on, and then be sure to verify whether you're a left-tailed, right-tailed, or two-tailed. Now I'll show you that that's the degrees of freedom, just like it did for confidence intervals, affects the values. Like if I go back to the z distribution, I'll pick any of these, doesn't matter. I'll leave that 0.05. I have 60 of there as a sample size, and you see that critical value is negative 1.645. I could change this number to 80, and the blue number is still the same. I'll do one more, 100. So the z distribution is not affected by the sample size. It's going to be that value no matter what. Now the t, totally different. So watch if I change this number from 10 to 20, you'll see the critical value change. Negative 2.000. I'll just use a different number here because it's going to be positive 2.00 if I just put 20 in there, so I'll use 25. So there's the critical value there, 1.974, and same idea here. All right, so the critical value does change, because it is under the guise of the t distribution, where they're bell-shaped, but they take on different shapes based on the sample size, bell-shaped and symmetric. And then the idea is that as n gets larger and larger and larger, the t pretty much becomes the z distribution. So I'll put in 200. I'll put in 200 here and show you. It won't be exactly the same, but 200's getting larger. So you see that critical value negative 1.8915, and I'll come over here to the z. I'll put in 0.03 and 200. And they'll be fairly close. I mean, the bigger the number, the closer it gets. So it's negative 1.88 here. And then it was negative 1.89. And as n goes up, they would start getting closer together. Now, once again, you don't need these commands either. I created this before I came up with that spreadsheet I just showed you, so that back when I first made these notes, it's just showing you the actual individual commands. So, but if you want to do it that way, you can. You have to put in, you see this, the Excel here expects you to put in the degrees of freedom, so you have to subtract 1. On my spreadsheet, you're just putting in the sample size, and then I already have it coded in the spreadsheet there to subtract -1. I have the commands there just sitting there for you to see. Yeah, you see right there, for example, is it B7 -1, so it's subtracting the sample size. So that's all right. You don't have to worry about doing it that way. Like I said, you just get these right off the other spreadsheet. So look at these. It's a left-tailed, so your rejection expression is going to be if t is less than your critical number, left-tailed. So what is it, 0.10 and n is 11 for left-tailed? And there's your critical value, negative 1.372. Oh, wait. 13722, okay. And right-tailed, 0.01, n is 22. Um, 0.01. 2.5176. There it is. This one's two-tailed, 0.05. So you can reject if t is less than the negative value or greater than the positive value. And that's going to be, so 0.05. And there they are, negative 2.447, or however many decimal places I used in the notes. Okay, 24469, but obviously the same thing. Now, p-values, which I in the past have not done for the t distribution because it would have required technology, but now that everyone's allowed to use Excel and even on exams, we can go ahead and incorporate p-value into the questions. But the z distribution, it can be done by using the normal chart, which then again I didn't show it there either because of using the spreadsheet. So now we're going to use them, but that's no problem. It's going to be right there in your spreadsheet, just like it was for the z. I mean the t. No, the z. I'm sorry. The t will have it, and just like the z will have it. We're now going to be using these. So So we'll knock out a few of these, but obviously I already have the Excel box here. The fun part's going to be where we have to do, problem I'll show you out of the homework where we create this from scratch. So, okay, we'll do a couple of these. Then I want to jump down to one that has individual data values. So we'll have to do something a little extra special for that. So let's see what this says. A computer repairer believes that the mean repair cost for damaged computers is more than $95. To test this claim, you determine the repair cost for 7 randomly selected computers. So they tried to sneak a fast one in there with a word as a number. But there it is, 7's you're in. And there's the mean repair cost. There's a standard deviation at 0.01. Do we have enough evidence to support the repairer's claim? And then there's the sentence in there about assume the population is normally distributed. That's what allows us to use the t-distribution. Now, we're not doing any other kind of methods, but technically, if that's not there, and it should be there in the test questions, but if it's not, just go ahead and treat it as a t if it gives you the sample standard deviation. That just means I forgot to put it there, but that sample standard deviation, that's our t. But like I said, that sentence, and then this last sentence does not have to be there whenever it's a z distribution, because we will have the population standard deviation. That's all we need. So just like the section on the z, obviously it's very important that we read this and set this up correctly. And I don't like to make the wording be too tricky, so this one's not too tricky. More than 95, more than means greater than, that's our claim. And then greater than always pairs up with less than or equal to, and that's the setup for a right-tailed, which you can have that reference to look at. This is always when it's less than or equal to, and greater than is always a right-tailed, same as it was before. So I'll come over there and enter the numbers, I guess, even though they're right here, so you can see me do it. But so it's right-tailed, 0.01. Sample mean is 100. And we're comparing it to 95. So also, just like the z distribution, be very careful that you don't get the two means reversed. I've seen that happen before. The sample mean is whatever the mean they give you in the data. The hypothesized mean is the number that you're testing against. So that's just be real careful. That's another thing. So if you're not getting a right answer, look for that, to see if that's a possibility. I believe this is 4250. Obviously, I'll go back over the spreadsheet here in a second. I believe that's correct. I recognize that p-value. So you can look at this one of two ways. I did it with rejection regions and p-values. That's supposed to be a picture of a normal curve there. I don't know why that's not showing. But anyway, I'm just showing that the critical value, I don't know why that's not there. 3.143. And then your test statistic 0.3113 is not greater than 3.143. It does not fall over to the right in the rejection region. So we do not reject the null hypothesis. And then the p-value better lead to the same conclusion. And it does. The p-value of 0.383, that's greater than your significance level of 0.01. So if p-value is greater than the significance level, which is also known as alpha, you do not reject. So since we're not rejecting the hoe, that means there's not enough evidence to support this claim. We can't say, we don't have enough evidence to support that it's greater than 95. You might look at that and go, well, the sample means 100. Yeah, but everything's taken into play here. The standard deviation, the sample size. It's harder to reject with a smaller sample size anyway, because it kind of makes sense statistically. The larger the sample size, the better the results. So it kind of, okay. All right, so we don't support the claim. So one thing to always remember, we're supporting the claim. The claim has to be the alternative hypothesis, and you have to reject the hoe to get to the alternative. If the hoe is the claim, and failing to reject, that does not mean you support it. Statistically, that means you just don't have the evidence to say it's wrong. So it's the same logic as it was in the previous section with the Z. It means you don't, okay, if you don't reject the hoe, it doesn't mean you love the hoe. It just means, okay, we don't have the evidence to say it's wrong. All right, here's an example. A local brewery distributes beers in bottles labeled 12 ounces. A government agency thinks that the brewery is cheating its customers with the bottles less than 12 ounces. Uh-oh, that's no good. That might be a hate crime in Texas, shorting people of their beer. The agency selects 20 of these bottles, measures their contents, and contains a sample mean of 11.7 ounces with a standard deviation of 0.7. Use a 0.05 level significance. Assume the population is normally distributed. All right, that just gives us our criteria to use the T distribution. So less than, okay, less than is pretty straightforward, nothing weird there. And less than would have to be the alternative, the ha. That means it pairs up with a ho of greater than or equal to. And let's see, we're going to have to see if we reject the ho to support the claim. I won't retype the numbers in the spreadsheet on this one. Like I said, you're going to see me do it in homework problems. So let's see so our using decision regions, we reject the ho if t is less than negative 1.7291. And negative 1.92 is less than negative 1.729. Another way you could look at it is if you flip it over completely to the other side, because the curve is symmetric, that would be the same thing as saying as positive 1.92 is greater than positive 1.729. But actually, you can just use the p-value to make it really clear. The negatives can be kind of tricky. But it is. The test statistics, negative 1.92 right there. Well, negative 1.9166. That does fall in the rejection region coming from this critical value right here. So it's in there. We reject. P-value. You see the p-value right there where it always is, 0.035. The p-value is less than your significance level of 0.05. So we reject. So obviously, it's got to lead to the same result both ways. It can't be, reject one way, fail to reject, no chance. That just means a mistake was made. So that means we reject the ho. And we do have evidence to support the agency's claim that the mean bottle amount is less than 12 ounces. It's not absolute proof, but we support it statistically. So somebody's in trouble for the beer shortage. Let's do this one. See maybe what. Yeah, I'll leave that last one there. Maybe it'd be a good idea to look it over, but I'll jump straight to the homework from here. That way we've done a left-tailed, right-tailed. Now we're doing a two-tailed. Now this one, when it gives you individual values, and if I put this on a test, I would not give you very many numbers because you have to type them into a spreadsheet. Now you'll see we have the last problem in the homework has the numbers, but it doesn't matter how many because you just dump the data Excel in there and do the commands. You don't have to type them in there. But here you would have to type them. Let me just kind of show you. Like I said, we're going to see this done live here. So for all, let me just look at the problems. Claims average GPA for all UHD students is 2.8. Is means equal. So that's going to be an equal, not equal. That's our claim. Not equal. So we have 8 selected students with their GPAs. So what you have to do is enter the numbers in there, and it's just see it's not giving us the mean and sample standard deviation. No problem. We have two Excel commands to do that quite easily. So you see I have equals average. Well, okay, I don't have the entire spreadsheet, but obviously assume that that's the first column is A. That is A1 to A8. I guess maybe I could have copied the headers there or whatever, sorry. And then here is your STDEV.S, which means sample standard deviation, A1, A8. So you can then, we have 0.05 level of significance. We have 2.8 for the hypothesized mean, and we know that 8's the sample size. So now we just take these two numbers and enter them here for the sample mean, and then there's the sample standard deviation. So we had to do a smidge more work there, but you didn't have to use any formulas to calculate the average or the standard deviation. You just had to use those Excel commands. So we have let's look at our decision rule. There are the critical values. Here they are right there. So that means you're going to reject the hoe if t is less than negative 2.365. Or if t is greater than 2.365. There's your test statistic, 0.907. And of course my curve is not there, but you can see everything you need here. So I have the two outsides. If it falls in the outside part, the shaded part, that's reject. But 0.91 fits between those two. So it's fail to reject. P-value, there's your p-value is 0.3943. So your p-value 3943 is greater than the 0.05, means you do not reject the null hypothesis. So here's what I was saying earlier. So here's where it applies to a problem. If the hoe was the claim, which it was in this problem, and you don't reject it, it doesn't mean you support it. It just says we do not have sufficient evidence to reject the claim that it equals 2.8. So that's the wording there is a little, you have to, yeah. But you don't support it. You only support the claim is if it is the alternative and you've rejected the hoe. That takes care of that. Let's jump over here to the homework. Let's see if we can have some fun over here. I brought that up. Where'd it go? 9.3. I kind of already know which problems I want to do here. I've already taken one of them off I didn't like. I'm going to do 1, 2, 3. Oh, forgot. Let me see which one's the, because I know I omitted it, so you probably won't see it now, but let me see if this is the one I omitted. I'll know there was something in there I didn't like. Yeah, it's this one. Formerly number 4, so that may not be number 4 anymore when you look at it. So I'm going to do 1, 2, 3, 5, and 9. And this one's really kind of a no-brainer here. Degrees of freedom. All you have to do is, I just put that problem in there just so people would realize what degrees of freedom, what it is, and how to calculate it, but it's super simple. Because I know on my spreadsheet you don't have to actually enter degrees of freedom. Maybe it was my fault for not setting it up that way so people would have to think what it was, but oh well, it's too late now. Let's see. So we have it's your n minus 1, your sample size. So 25 minus 1, 24. There we go. So 1, 2, 3, 5, and 9. So let's take a look at this one. Let's see if I can zoom in on this a bit. Where's... Oh. No. Can't figure out. Well, that's all right. I won't worry about that. Where's the... Oh, what was it? Hitting the right thing there to zoom in. All right. I can't find the plus key. Let me try Control Z. Now, what do we got? Never mind. So, so it's just telling. So it's, instead of giving the ho and ha, which we're going to be setting up, ourselves, but this is more just straight calculation. It's telling you it's two-tailed. Don't plan on it necessarily telling you that in test, which it might, but some problems you're going to have to interpret it, obviously. We do not need this T distribution table. That's why I didn't even bring it up or I didn't even talk about it. It can all be done from that spreadsheet. So it's alpha 0.02, n equals 5. We don't need anything else to get the critical value. We would need, if it was calculating the test statistic, we would need that. But it's 0.02, two-tailed, n is 5. Right here. N is 5. So there are the critical values. Let's see how many decimals it wants. So it's going to be answer B for sure because it's the or. Oh, there. Oh, this. I'm sorry. Let me do this first. It's going to be the same numbers up there though. They want nearest thousandth, so they want 3 decimal places. Negative 3.747. And excuse me. If you have 2 of them, you use a comma to separate. And this is two-tailed. It's going to have the positive. I just didn't say the positive one, but yeah. So you have to do it like that with a comma, and that's what we'll put over here. Negative 3.747. Then positive 3.747. Alrighty, that was all that question involved there. So now we're going to have a little more detailed problems. I won't even go. I'll go back up and read this information here in a minute. But to answer this, well, actually, I should say it. It's giving you. Now on a test, I generally make this clear, but I want to specify something when you're doing on this on the homework. If it's going to be population standard deviation, it's got to really say population standard deviation, but this is a sample standard deviation. I'll tell you why. Because all part of this same sentence where it says random sample of 7 cars has a mean gas mileage of 23 and a standard deviation of 2 miles per gallon. So that's implied that it's a sample standard deviation because it's coming from that same sentence as the random sample of 7 cars. All right, so I think on the test I probably would make sure it says sample there. I certainly would for population. I can double check that to make sure, and I will. I'll edit it if I need to. And the idea is it says assume the population is normally distributed. What do we use here? We use a T because the population is normal, and sigma, that's the symbol for population standard deviation that we've seen before. That's unknown. So that's the answer you're looking for there on that. And let me go down and go back and read it. It says the mean gas mileage is at least 24 miles per gallon. At least means greater than or equal to. Greater than or equal to has to be a ho because it's got an equal in it. And therefore it has to be D. And then it pairs up with less than, which means it's going to be a left-tailed test. So we're saying we don't agree with it. So since we don't agree with it, we hope the numbers work out that it rejects. And that means we're going to support that it doesn't equal that. Excellent. Test statistic. Now I got to enter the numbers in there. So 0.05 significance. 24 is what we're testing against. The sample mean is 23. This is left-tailed. T. 24 that we're testing against. 23.05. And I need the standard deviation, and I need the sample size. Where are you? There we go. The standard deviation is 2. Sample standard deviation. And where is 7 cars? Okay, there it is, 7. 7s are in. Sample standard deviation is 2. So that should be everything we need right there. I believe it was asking for test statistic first. Let me see how many decimals it wants. 2. Never know what it's going to want. Oh, spreadsheet. 2 test statistics, so I'm going to go with negative 1.32. Hooray for us. Critical value, 3 decimal places for this one. So you never know what it's going to do. 3 decimal places, it's going to be negative something. There it is, negative 1.943. Let's see how we did there. Got it? Now, we could sketch this on a curve and it would show that the negative 1.32 is not beyond, it's not out beyond negative 1.943, not in the critical, it's not in the rejection region. But you know what you can also do here, because it might be asking that here in a minute. It certainly is going to be on another problem, but we can actually, since we have the p-value right there, let's just use that, and that'll make it a little more clear. So alpha was 0.05, p-value of 0.117 is greater than 0.05. So that means fail to reject. And like I said, the test statistic was not in the rejection region either, so it clearly fails to reject. So back to this, and fail to reject. There is insufficient evidence to reject the claim that's at least 24. Yeah, we can't say we support it. We can just say there's not enough evidence to reject it. Hooray! So let me that one off and we'll jump up to 5. I said 5 and 9. The Metropolitan Transit Authority mechanical bus of 3,700 miles. And let's suppose 100 buses, sample mean of 3750, sample standard deviation of 325. So this reliability goal of 3,700 miles. Of is like is. It means equal. All right. So this should be an equal, not equal. Two-tailed. 3,700. 3,700. Oops. What? Let's see, maybe. Okay, I see my mistakes. I thought everything was up there in that problem. This isn't going to happen to you on a test. Everything will be contained in the same problem. But this is what it was really asking, not here. More than. Okay, so that, all right, well, my mistake, though. This will be greater than. That'll be less than or equal to. I thought it was coming from up at the top, but it was not. Right there is where it said it. Is there enough evidence that it's more than 3,700 bus miles? Okay, well, test statistic. So 3,700 is our hypothesized mean, and 3,750 is the sample mean, 0.10, and it's two-tailed. So we're going to make sure we're on the right area in the spreadsheet. Two-tailed right down there. 0.10. Let me double check this though before I think that's 3,750. The next one I know is 3,700. I think there was 100 buses, but let me go ahead and just check carefully. Yeah, so 3,750, 100 buses at your end, sample standard deviation of 325. Yeah, I like the fact they put the said sample in front of that. 325. And it won the test statistic, and I didn't bother. I always forget to look. See, I mean, 2 decimal places. I forget to check before I go away, but it's no big deal. So I'm going to go with 1.54. Got it? The critical values are, what was it, 2 again? 2. So negative 1.66, positive 1.66. Nope. Get away from me there. Negative 1.66, comma, positive 1.66. Wait, well, I guess I wasn't. Negative 1.66, positive 1.66. Wait. Did I mistype these? Let's see. Okay, I realized what I did wrong there. You probably saw it while I was doing it, but it didn't hurt anything. I'll show you. This was a right-tail test. I don't know why I was thinking of two-tailed. I was just stuck on the last problem. So what I did is I copied all the numbers from up here to here. Now, it didn't matter. So you see the test statistic, that's calculated the same way. It wouldn't matter as right-tail, left-tail, two-tailed. So that's why I got that part right. But as soon as I entered in the 2 critical values, that's what's wrong. So this 1.29 should be correct now. So yeah, to get the test statistic right, any of those will generate the correct value. But you know, we don't do it like I did. Just do the wrong one. 1.29. Pay better attention. I should be paying better attention, or maybe not making videos at 2 in the morning would help too. Okay, there it is. So the test statistic 1.54 is greater than the value 1.29. We can also double check that with the test statistic. We can do the p-value. So there's the p-value up there. 0.06 is less than 0.10. Be careful. It's not less than 0.01, but it is less than 0.10. So you would reject. So we're going to reject on this one. reject, and then what was the claim here? More than. So reject the whole means we're going to support that claim that it's greater than 3,700. See, there's two reject answers. So you got to pick the right one. It's that one, because that was the alter was greater than. All right. P-value. Okay, I just saw that a minute ago. Let's get that right here. But you see, even though we hadn't asked for it yet, it's still, we were able to use it if we needed it. Oh, 0.064 if it's using 3 decimal places. Let me see. Yeah. Okay, this, I won't really ask this on a test, but it just, when you see these in the homework, look for that wording. Don't worry about that as far as being on a test, but just pick the answer where it says probability against sample mean that's actually greater than your sample mean if the mean was, actual mean is 3,700 miles. Now, of course, if it's a left tail test, it'll say less than, and I forgot what it'll say if it's two tail, but just look for that kind of wording. But I will not put that on a test. I guess that's completed now. We're going to jump down to number 9. That'll be the last one for the video. So this was like the one about the Big Daddy and the GPA. So like I said, here you got a lot more numbers, but no problem, because we'll just we'll dump the spreadsheet here. So there they are. And I'll come over here and I'll put the formula text command just so you can see what's about to be put in those two columns. C1. Then I will drag the corner of this down right there, the corner, so I can copy to the next cell. And we're going to type in average. A1 to A18. So it's A1 to A18. And 31. Just trying to center that. I don't know why it won't let me center it. Oh, that's in the wrong place. Okay. Oh, that was a height. Okay, I see. And then Std Dev.s of A1 to A18. There we go. So I got to put those numbers. Now this is, well, I don't even know what test it is yet. I got to see. Just have that ready now. So let's see what we got. What's it saying? Okay. So yeah, this one, unlike that one problem where it didn't give the type of test it was until the part A. Here, that's what fooled me on that one problem. But here, now it's right there. So yeah, it got me on that one problem where I didn't realize it was down there in the wording. Fewer than's less than. Less than's an alternative that pairs up with greater than or equal to. So I'm looking for a less than, a greater than or equal to, ho, and I like answer F right there, which means this will be a left-tailed test. So that's going to be key which one I pick here. Oop. Left-tailed right there at the top. Let me get some values here. We are testing against 33. There were 18 classes we selected, 0.10. 0.10, 18 classes, and we're testing against 33. I'm going to double check that in case my memory's off. Now we have to put in the mean and standard deviation that we got. Let me just double check that real quick. So like I said, this one just didn't give us the mean and standard deviation, but we were able to easily calculate it with Excel. Yes, 33, that's correct. So let's come over here. Get those values. Now I want to show you something. Okay, I'm going to just type in 31. So if it had a bunch of decimal places, I'm going to show you a little trick for the next one. And when I show you this, you can easily choose not to do this. You can just say, I'm just going to type the number in there. I don't care. But it's just a little Excel thing that might be worth knowing. You may already know. So I'm going to put 31 in there manually for the sample mean. Now I come back over here. Now because we used a formula here, if you want to copy this instead of typing the number in, you can do that, but you have to paste it in a special way. You can't just use normal paste because it'll be copying the formula and it'll mess everything up. Because we only want the numerical value. So if I come over here and paste and I click the drop down, right there, paste value. So that way it just takes the number and not any of the commands that generated the number. So you might say, okay, I don't care, I'm just going to type it, but it's not a bad little thing. So there we got it right there. Everything we need. P-value, I believe, was first it asked. I'm going to say 044 if it only wants 3 decimal places. I can fix that easily enough if that's not right. 4. So it's 0.044. Fantastic. Okay, it's asking straight up reject already here. So the p-value of 0.044 will be less than 0.10. Once again, be careful the difference between 0.10 and 0.01. 0.44 would be greater than 0.1. And we're going to reject, and we support the claim of less than 33. Oh, here's just telling you, oh, okay, it's not even asking that yet. Maybe it will down here somewhere, I don't know. Because P is less than your significance level. Okay, so let's see. This is the last part of that question. So we're going to, all right, let me look at this one. I like answer C here. The claim is the alternative, fewer than 33 students. We support that claim because we rejected the hoe. So that should be the right answer right there. Got it. And that will conclude this video on hypothesis testing, population standard deviation unknown.